I hope this screen is visible, right? If it is visible from your side, just give confirmation. This blank screen is visible to you.
Yes.
Okay. Okay, so we have seen how the convolution process is actually accomplished, right? And one examples we have already seen, in which we have seen if you have been given a two signal x of you have been given a two signal, one signal is x of tau and another signal x of t, let's say, and another signal is h of t. So finally convoluting this x of t and h of t, you can produce a signal y of t. So, and if this is a discrete time signal, if this one is also h of t is also a discrete time signal, so we have seen this convolution x of t and h of t will be turned out as the k is equal to starting from somewhere, it's just a overlapping area, it just represent the overlapping area from minus infinity to infinity, x of k into h of n minus k. So how what process we are doing over here is, the first process is convert h of k into h of minus k, right? And this operation is known as a time reversal operation. The second process that we have done is we shift h of minus k to h of n minus k, right? And what is the value of n? So n is the shifting amount, or that is the shifting point, right? It is the shifting amount. And then we define n will be start from 1 2 etc, right? So this is the process number 2. So what is the process number 1 here? We convert the h of k to h of minus k, that is time reversal operation. Then we gradually shift the h of minus k by some amount 1 2 3 etc, and then every times we can find the h of n minus k, and this h of n minus k is multiply with x of k, and this is multiplication for all the points, right? All these points of overlapping. So that is actually the starting point of overlapping. We can simply define, sometimes it is better to define this one is some point as a t1 and this is some point t2. This is starting point of overlapping, and this one is the ending point of overlapping, right? So that way we can add these points, all these points, and that is assigned to value of y of n minus a. Repeat the process for another value of shifting n is equal to 2 3 4 all, and repeat the process. So that will be taken for n is equal to 1. Suppose that is taken for n is equal to 1. Now repeat the process for new value of n, take the n is equal to 2, repeat the process, and then find the y of n. And we will complete this process till we will find there is no overlapping between x of k and h of n minus k. Now this part we have already done and we are very much familiar with this part, but now today we will see this experiment in which uh, uh, by using a MATLAB toolbox, how we can proceed this in a MATLAB, right? So in this experiment today we will discuss the find the convolution operation between two signal, operation between x of x x of k signal, that is the set of x of k, and h of k using MATLAB toolbox, right? Using MATLAB toolbox. So we will see this how this process is basically done, right? So that for examples, just we will see the things over here first. And once we are very much familiar about the process, how it can be done, then we will transfer to the MATLAB. So I will sign off from this device and sign into my laptop, where we will see how this can be implemented in a MATLAB. And any programs you are making in a MATLAB, it should be general program. I mean, if you change the value of x of k and h of k points, then you will get the new set of phi of k, right? So every times you do not need to change the program, only the values are changed. Program should be generalized in the sense that if you change the value of the x and h, then you can have a new set of y's automatically produced. You do not need to modify any other syntax of a program. So that point we are going to discuss today, and especially here we will take one examples how the MATLAB will work on this one. So first, let's assume x has some points 1, 2, 3, 4, right? And h has some point. So h has some point, and how this h has some point. So h has some point is suppose defined as a 1, 3, and 2, right? We need to find the convolution operation between these two signals and produce a y of n. So very importantly that we need to define the time axis of x. So assume that is defined as here. I mean, so this is the point 0 point, and h is defined from here. Okay, so that looks fine. Now we will do for such kind of cases. If you the cases are much more complex, so it is then you need to modify the code in somehow. But we will go with very simple consideration of this one. And here, what is the time axis x? So that the time axis of this x is t1. The first is 0. 0 is starting from here. So that is the 0, 1, 2, and 3. So it will be appear at this time points 0, 1, 2, and 3. It means at t is equal to 0, we have amplitude value of 1. As t is equal to 1, we have amplitude value of 2. And that you can correlate with x axis and y axis. So whatever the values in x, that holds the amplitude values. And whatever the value in t1, they holds the time axis value. The same way for T2 is for H. So for that one, what we write here, we can write here, this is nothing else, but this is the 0 point, 1 point, and 2 points. So T2 has a 3.01 and 2, and corresponding amplitude values are 1, 3, and 2. So first part, we have to find the things how we can produce a y, the amplitude values, and then we produce a time axis value, and then then we correlate them one by one and plot the graph of t versus y. Right. So before producing this time axis point, first we produce the amplitude. So the amplitude is the first operation is the flipping operation. So right, flipping operation. So after flipping operation, what happens? This h of 132, it becomes a 231, right? It becomes a 231. It is reverse after applying the flipping operation. Now this flip operations we can simply define as h dash, right? So this is the original sequence and this is the flip sequence. Flip sequence. The MATLAB command which will do this job, the MATLAB command here is to flip the operation is known as a flip LR. The flip command that we are using for this operation is known as a flip LR command. Right? Okay. Now, after doing this, what we do, if we multiply the two numbers, two sequence, so in MATLAB, it is essential that both the numbers have a same number of elements. So here we can see X has a 4 elements and H has a 3 elements. So we cannot combine them together. How we want to arrange them? So we want to arrange them for n is equal to 0. First, we start with n is equal to 0. We can arrange them in such a way so that we can have a 1 x of k should be of 1, 2, 3, 4, right? And h of k should be sorry, should be starting earlier from this x of k, and h of k should be start from here such that the first element h dash actually, right? H of h dash we say it's because h dash is a flip version. So that is the 2, 3, and 1. I use the different color. 2, 3, and 1, right? So what happens if we try to multiply such sequence? Then there is a issue. What is the issue? That the MATLAB will tell how can we manage, because that is the three elements in h dash of k. In x of k has a four elements, so it cannot be multiplied point to point. So to make the sequence same, the number of points in a same, that we add some extra number of zero here. And how many number of zeros? So 30 we have added. And what is the length of x of k? Length of the number of elements in x of k, there are four. So that is just a similar number. This number of zero padded zeros at the end, padded zeros are L minus 1, right? L minus 1 zeros we are padded at the end of h dash of k. So L1 is the length of x of k. So how many numbers? Because one is correlate, right? One is combined. So remaining bits are three. So three zeros are padded. The same way we are doing for x of k. In x of k, we need to padded some zeros, but that should be padded in a front rather than in a back. So here, how many numbers of zero we need to pad? We need to pad this first zero and second zero. And this number of padded zeros are is actually here we say length of this length of L, length of this sequence earlier, before padding with zero. Before padding with zero, there are three bits are there, right? 2, 3, 1. So that length we are saying. We are not saying the length after padding the zero. It's a before padding the zero. So before padding the zero, h dash of k is a three elements. So that is the length of three. And here we are padding the 2, 0, means this padding, this is padded zeros, zeros of L minus 1, right? L minus 1 means the number of elements in h dash of k is L2, is the length of number of element, is the number of elements in h dash k, that minus 1. That number of zero we are padding. So now we can see the sequence. If you see the sequence, so they have all have a six elements. X of k is a 1, 2, 3, 4, 5, 6 element. H dash of k is a 1, 2, 3, 4, 5, 6 element. Now we can multiply them together. So after multiplying them, whatever we are getting is known as a y of n. But as n we have considered as a zero, so that is the first element where n is equal to zero, that is of y of zero. And if we multiply them together, so we multiply here this two, then we multiply here this two, then we multiply here this two, we multiply here this one, and this one. So we will multiply here all this element point to point. So first we multiply with 0 and 2. So what we are getting here, the output would be a 0. Then we multiply 0 and 3, then that is 0. Then 1 into 1, 1, right? And here we multiply, then after 1 into 1 we are getting 1 here. The same way we are multiplying 2 into 0, then let me know what would be the answer as 0, then 3 into 0, then 0, and then here 4 into 0, then 0. And then we are taking, this is the addition, right? Because here we have equation says must be added. Because of this additions, we have to take the sum, right? We have to sum of this all, we have to add up this all. So in a MATLAB we have a command of sum. Sum is a command. We take the sum of this. So 0 plus 1, then that is added with this, all will be added. So finally we are getting here, the final answer would be a 1. So it means y of 0 we have got is 1. Now next time what we will do, we will take n is equal to 1. I mean, so this h dash of k is shifted by some amount, one amount, right? So then what happens here? Then we can have n is equal to 1, right? When n is equal to 1, then our x of k is not going to change. It remains same. 0, 0, 1, 2, 3, 4. Nothing is changed. But now h dash of k is shifted by 1 in the right side. That is h of n minus k, 1 minus k, right? H of n minus k, but n is equal to 1, so that is 1 minus k. So that is 1 minus k, means the things are shifted here. And this 2 which is appear below to the first elements of x of k is now shifted next here. 2, 3, 1, then 0, 0, and 0. Now this 0 is not required here, because here it is not anything to multiply with x of k. So this 0 is shifted over here. this 0 is shifted, and it will be cancelled from here, right? So this 0 is shifted. So for that one, what is actually we are doing? We are doing the circular shifting by amount 1, right? So every times we do this, so the MATLAB command, the MATLAB I just write here, this the MATLAB command for circular shifting, MATLAB command for MATLAB command for right shifting, laps, I think it is right shifting, right? Right shifting is known as a circular shifting. Circular, it means circular shift with shift every bits in a right side, and the last bit is to be put in a left side. So it is circular shifting, right? Everything is circular shifted. So this is the command, MATLAB command. If we are using this command, and how many points we are shifting? One single points we are shifting. So we say the circular shifting of h dash of k, h dash of k elements with the circular shifting amount 1, right? So that way we can do. Now again we will find here the y of n. So what would be the y of n? If we are multiplying, then it's a multiplication here, right? Not addition. So 0 into 0, that we are getting here the 0, 0 into 2, then 0, 1 into 3, 3, then 2 into 1, 2, then 3 into 0, 0, then 4 into 0, 0. Okay, now this is not a y of n basically. The y of n is actually the summation of all, right? Y of n is the summation of all. So summation of all is the 5, but n is equal to 1. So here that is y of 1. So y of n we have obtained is a 5. And the same we will do for a next process also. So for a next process, the last process we will complete, and then the similar way you can find for all other elements and all. And how many times we have to do this process? So till this 2 will not crosses this 4, right? Till it will not crosses this 4. So we need to do this process for L1 plus L2 minus 1 time, right? That we will see. So now we can do the same thing for n is equal to 2. Again, the things are not looking different, that looking the same, that x of k is not going to change, that is 0, 0, 1, 2, 3, 4. But now, as per the circular shifting operations that we are applying over here, h dash is becomes a h dash 2 minus k, and this h dash 2 minus k is the 2 is basically starting from here because it is more shifted. So this point is shifted here, this point is shifted here, every points are shifted 1 point. So 2, 3, 1, and then 0. This 0 are shifted here, that is 0, 0, right? And then this if you find this y of n is actually the summation of all this point, that is 0, 0, 2, 5, 3, and 4. And if you take the sum of this all, so 2 plus 5 plus 3, sorry, 0, 2 plus 5 plus 3, so it is 10. So y of 2 is equal to 10, right? So that way we can identify this point, right? This point we can identify in this way. So this is very interesting thing. And one more important thing is how much points we need to do. I mean, we repeat this process for how much times, right? How much times this process will individually done over here, but in a MATLAB code we are using the for loop. So for loop will do this process every time. It will do the same process with the shifting version of h, with the shifted version of h. So how many times this for loop is basically rotate, for loop rotate. If we assign this duty to the for loop to do in iterative sessions continuously, so we need to find how many what is the maximum limit, means how many times this variables are changing, and for loops is rotate. So here we can say if L1 is a length of this sequence of x, and L2 is a length of sequence of h. So L2 minus L1 plus L2 minus 1 times this process will be repeated, right? Because the second sequence will totally crossing the first sequence. So they have to pass through every times but the last element of h should be passed through the last element of x. So that will be take the number of iteration of L1 plus L2 minus 1. So these are the total number of iterations required. So now we will see this process. Okay. Now, but if you want to plot this y of n, right? So after this process, let's assume you have a y of n is available with some different values, like as a this values are there. We can start with this first value is a uh, 1, then we have a 5, and then 10. So we can say y is 1, 5, 10, and we have some more values are there. So actually we require this time axis also. Because of this time axis, we have some value of 0, 1, and 2, and then we will plot this graph of a t versus this y. So we require this one 0, 1, and 2, and all, and then we can plot this graph of 1, then 3, then 10, like this. Right? So for that one, what is important is this time axis should be available. So for that time axis, we have already defined earlier what would be the how we can find this. So in earlier we have already described this equations, and in this equations we have defined how it can be signed. So we move to that equation, just to hold it. Yes. So in this one we have defined this is the t maximum, right? T maximum point is the minimum value of t1 plus the minimum value of t. So if we just take it, this is the minimum value, and what is the length? Then t maximum value is t minimum value plus L2 minus 1, and L is the length of t1 plus length of t2, right? So we can say this t minimum here, this t minimum here, this point is this point is known as a t minimum point, and this final point somewhere here, that is known as a t maximum point. So how we can find this one? So t minimum point is the minimum value of a t1 sequence, right, plus the minimum value of t2, right? And that we can say the t max is nothing else but it is the t minimum point plus L minus 2, where L is the length of the first sequence T1, this is L1, and L2 is the length of the second sequence, which is known as a T2. And if we add them together, then we can have a L1 plus L2, and that L is this one. So this is very important equations to identify the T, the time axis value, and any time T can always be start with the T minimum moving with the T minimum plus 1. The next point would be a T minimum plus 1, then T minimum plus 2, then finally the last is T maximum, and this point is this T maximum minus 1. So that way you can have a time axis. Now the same part we are going to do with the MATLAB code, right? And hope you understand this conceptual idea, and we will see how using the MATLAB toolbox and by applying such kind of a logics we can convolute the two signals together, and whatever the output is produced we can plot this, right? Okay, so we will see this. You just hold on. I'm just going to switch over from this device to my laptop. Okay, sorry for delay. Actually, there are some issue with my laptop or maybe internet, right? I'm not able to log in from my desktop to this MS Office. Okay, but anyway, we just take a look about how it works. I will just open up MATLAB on my iPad, even though it is a basic version, an application version. So we'll not able to do too much things over there, but at least we can see how the things can be happens, right? So I'm going to open from my iPad and let's see MATLAB is there or not. Yes, the MATLAB is there. Are you able to see this screen? This MATLAB screen, are you able to see this MATLAB screen?
Yes, sir.
Okay, so we write the code from here. The first code that we are writing over here is to take a two sequence first, right? So first we write here the CLC and then okay, so CLC and then we first produce the sequence code sequence X. So we arbitrarily assign any sequence of this one. We assign that X is nothing else but X is equal to square and then we assign some value 1, then 2, then 3, right? And then we complete or close this one with the with this, right? So that is our X, right? Same way we will produce a H, right? Or H can be produced with similar way. We can assign H is equal to anything we can assign as a T 2, 5 and 6, maybe 7, right? That can be assigned. Okay. Okay, so we have assigned X and H. Now, what we do the second portion is we paid the number of zeros. But before that, we need to flip H, right? So 2567 should be appear as a 7652. It's a reverse. So we assign with the same value, and H is equal to flip LR. We have a command known as a flip LR. This flip LR is assigned, and in this flip LR, what we will do here, the flip LR, and inside a bracket we assign H. So H is flip and then again assigned to the H, right? So that shows the same thing, again assigned to the H. Okay, now this is the flip LR. So after flip, we assign the same. Now we want to append the number of zero. So before this, here it is the point where we define the length of both the sequence. So we can start with the length of L1, and this length we can assign is equal to we have a command of to find the length, and that is known as a length, LENGTH, and inside we write the sequence for which we are seeking the length. So it is X, right? Then we will repeat the same process for H. So that length of sequence H we can assign to the variable L2. So L2 is equal to the length of H. Right. So now we have assigned the length of the two sequence. Length of x is assigned as the L1 variable, and length of h can be assigned to the L2 variable. Then we have flipped the h. Then there is a time to append some number of zeros, right? So we append this. We create a new sequence of x. Now in x we append the zero at the back, and sorry, in the front, right? And in h we append the zero at the back. So in x, we can see x is equal to the length. Yes, we make the square bracket first, and in square bracket we write inside a square bracket. Here we write the first part is the number of zeros, right? Number of zeros, and how many zeros we want to add, which size should be 1 comma, means first row, and 1 comma the L1. We have already find the length, right? So L1 is L2, sorry, L2 is the length of H sequence. So L2 minus 1, L2 minus 1, right? That number of zeros are produced, and this all zeros are assigned append to x. So x is there. So this command, what this command will do, this command will take the x and append some number of zeros before the x, right? And how many number of zeros are append before x? So that add the length of h is L2 minus 1 number, L2 minus 1 number of zeros before x, right? We repeat the same thing for h. We repeat the same thing for h. Now the new sequence of h is assigned as equal to, now here we append the zeros at the back side. So the first one is our original sequence h, and then we can add the zeros. How many zeros? Which size is 1 comma length of first sequence. So length of first sequence means L1 minus 1 number of zeros are appended at the end. Right. So what we have done here, you see the first in we have appended some number of zeros in a front of x, right? And in next sequence we have added some number of zeros. I think this command is wrong. It says zeros at the back of h, right? So we have done this, and now it is a time to multiply this, shifted and multiply. So for that one, this process is repetitive process. If anything is repetitive process, so we can put it inside a loop, any of the loop. So for that one we choose the for loop, and for loop, the sequence is actually starting from I is equal to 1. We have to give the last values up to how many times this loop will rotate, so that we can say is we have already defined earlier, it's L1 uh, then plus, where is the plus, plus L2 and L2 minus 1, right? So this sequence is repeated up to that minus 1. This loop is ending, but in between what we have to do, we have to multiply this two sequence. We have to multiply this two sequence and assign in a y. So but every times y is actually a single value, so that we have to assign this one y of I. Y of I is the iteration, and then we can say is equal to, and here we write the sum, right? That will be multiply and then added. So that is the sum of what? So sum of point to point multiplication of sequence x dot, we are using the dot because it's a point to point multiplication, it's not a matrix multiplication. So x dot h, and then we will close this one, right? We will close this. So what does it means? It means every point to point multiplication means first elements of x will be multiplied with the first element of h, second element of x will be multiplied with the second element of h, and etc. All will be multiplied point to point, then they are summing together, and this single value after summing we have a single value that is assigned to y of I. Okay, now we are ready for a next iteration, but before the next iteration, what we need to do, we have to circular shifting. So sequence of h will be shifted by 1 point, and the last zeros are appended in the front side. So that's why here the commands that we are using here is known as a circular shift. Is CIRC SHIFT. This is known as a circular shift, and this is the circular shift of what the sequence. This circular shift is the sequence of this will be assigned to actually the h, right? That is again assigned to h. So circular shifting of h, but how many points? So there are some single points. Means only single point is shifted, and then we ended with a semicolon. So that is the circular shifting. Every time h is a new value, h is every time a circular shifted, and then we multiply. Then again we circular shift h, and then we multiply. So this process will be repeated till the total number of iterations are not crossing L1 plus L2 minus 1. So that way we will find. Now it's a time to display, and this is the time to display these two sequences, right? And this display is actually the display of y. Here I have not managed anything for a time axis. We have not managed anything for a time axis. That part is remains. That is left for your exercise. How to adjust the time axis and how to plot the t versus y. That is left for your exercise. So how you can find? You can assign the t1, t2 sequences by yourself, and then this sequence is correlated with your original amplitude value x of k. Then we find the minimum of t1 plus minimum of t2, that is t minimum. L1 plus L2 minus 2 plus T minimum is the T maximum value, and then T minimum to T maximum value we can make the array and then plot the Y versus that value. So that is left for your exercise, and whenever you finally submit me the file, so it should be according to that. You have to add the time axis value also and then plot the Y versus T. But here we are just showing the value of display of y, right? And we run this command. We need to check whether this sequence x123 and h2567 is actually matched with the actual sequence or not. So we first multiply. So if we multiply, we are finding this value 2, 9, 22, 34, 32 and 21. But we are not sure whether our code is right or wrong. So what we do here, we will take one thing over here. We will manually. Why I am putting over here this one, because otherwise the sequence is going to change. So here I will use the direct command, right? And this variable is suppose assigned as a y1. Then I use this direct command, and what the direct command is? The direct command is convol, conv. So MATLAB will do the same job with this command, convol. And here we directly convolute the two signal x comma h, right? It's a single line command, but you should know the basics of this. So that's why we have written the code. So convol, convhv, and then produce the y1. Now we have to check this y1. We have to check this y1 and this y are same or not. If they are same, so it means whatever the convolution will be computed by MATLAB, by the inbuilt function of convol by the MATLAB, it actually match with our function. So we have done the right job, right? So here we can go with this one y1, and then display this one again. So we check whether okay, so that's two sequence does match, right? First sequence 2, 9, 22, 34, 32, 21. The next sequence is also 2, 9, 22, 34, 32, 21. It means that whatever the convolution function we find, it follows the same logic of convolutions, and that it will be matched with the inbuilt command of convolution of the MATLAB, right? We can do this by changing some sequence of x or h. You can have some another sequence, and whatever the examples we have already then solved by using a tabular method and graphical method, by using those these commands, whatever the values we have manually calculated, you can put in here in this code, and that you can cross verify that things. So now I can have some different sequence. Sorry, we can have a different sequence, and here also I am changing this sequence and this sequence both, and then verify again for a next sequence whether it will be verified or not. So this is a sequence, and here I can put some other sequence like as a 4, 2, then 1, then again 1, and then 9. We will see for that two sequences, right? And we will check whether the both will match or not. So that is the sequence. Now if I run, so you find we have two sequences, 42119 is the sequences and 1568 is the sequences. Now what is the answer of convolutions? That is 4, 22, 35, 50, 36, 59, 62, 72. They are again match. So that way we can do this, right? Now if you want to add the time axis, then you can add, suppose x is starting from 0. So now this part is I am even doing, right? So not left for your exercise. Then what we can do here, we can assign this t1 is equal to, we have to assign how many points? 1, 5, 6, 8. So if you're starting from 0, then we can say that is 0, then 1, then 2, and then 3. So there are 4 points are there in x, so that is corresponding to 0, 1, 2, right? And we complete this one. The same we will repeat for t2. So for t2, what we can say, t2 is equal to, there are 5 elements are there, and assume that is starting from 0. So we can say it is 0, and then 1, then 3, then 2. Sorry, it may be in sequence, right? 0, 1, 2, 3, and the next one is 4. So we have already assigned this one. Okay, so T1 and T2 are applied. Now we create the T from this. So what is the T actually? So T is actually how we calculate the T. We need require L1 and L2. So I put here, I will calculate here the T, the time axis of Y, right? So T is equal to the minimum value of T1 plus 9. So first we find the T minimum. So then T minimum is nothing else, but uh, it is the minimum of T1, minimum of T1 plus then where is the plus sign? Yes, plus minimum of T2, right? Minimum of T2. So that we can consider as, this is the T minimum. Now what is the T maximum? So T max is basically nothing else, but it is the T minimum plus L2, L1, sorry, L1, and plus L2 plus L2 minus 1 or minus 2, right? So that part we have already done, minus 2. So okay, so Tmax is written over here. Now here we need this because rather than display, if we want to plot, right? So here what we require this T, the new T is basically vary from uh, T minimum to with a step size of 1 to T max. max, right? And is has an equal number of element f of y. So now we will plot uh, t versus y, right? We will plot, but rather than plot, we want to plot it discrete rather than because it's a not a continuous function of time. So for that one, we are using the another command is known as a step command. Now, if you run this one, so it shows this. So it's team, not step. This command is showing the error. It means this has some error. This command has some error. That is team. So we just wait. Yes, so finally you have got we have this signals are plotted, and this plotting is y. So I have not given the labeling because I am finding difficulty in typing in this ipad, but you can plot this x-axis, y-axis. So on x-axis we have 0 1 2 3 4 5 6 7 are the elements, and their corresponding values are 25, and all these values are plotted over there, right? You can give the labeling of this one, x label, y label, and title and all. So this is the graph, so convolution graph. So that was given to your exercise, but I have done this. But now it is up to you. You have given the graphs, and then you can verify this for others' values. Okay, so now I conclude the session over here. I hope you have enjoyed this journey of convolution through the MATLAB. Now I came back to the main screen. If you have any doubt, you can ask me the questions. Otherwise, I'm going to take your presence through this. So I'm taking your presence over here. The date is 24. Left. Okay. Now, what is the first number? Which one is the first number from where we can start?
49, I guess.
40?
49.
9. 49 is present.
Yes, sir, present.
Okay. Then 50
Present, sir.
is present. 51, 52, 3, 4, 5. Okay, nobody is present.
55, sir.
55. Okay, 56.
Yes, sir.
Okay, 57.
Yes, sir.
58. 57 is present. Okay, 58. 59.
Present, sir.
Okay, 60. 61. 62. Okay, if anybody is present, D2D student, now D2D 1, 2. Okay, nobody is present from D2D, right?
Sir, D2D 4.
D2D 4. Okay.
Answer 5.
5, 4 and 5. Okay, so now I repeat the numbers of present number of students today. 49, 50, 55, 56, 57, 59. They are present along with the 2D student, 4 and 5. Okay, is it fine? Anybody is remain? Okay, so now I conclude the session over here, and you can practice more using the software, right? So I stop the broadcast and then conclude the session over here. Have a good day to all of you.